Next rule is the quotient rule. Quotient rule telling you how to take the derivative of a quotient. The word quotient is synonymous here with fraction, ratio, f of x divided by g of x. The quotient rule is more complicated than the product rule. And it's harder to remember. I think most people think of the function in the numerator as the so-called high function. Really, you should spell that H-I-G-H, not H-I. And low function is in the denominator. You should really spell that L-O-W instead of L-O, though I won't mark it wrong if you use H-I and L-O for short. The quotient rule says that this derivative, I'll say it for fun, fast, and then I'll write it more slowly, is low d high minus high d low over the square of what's below. Or over low squared if you prefer. I added the b low in there because it just flows off the tongue better. Low d high minus high d low over the square of what's below. Low d high minus high d low over, yes, you could call that low squared. Okay, I'll write low squared. But when I say it, I say over the square of what's below, because it just flows off the tongue better. Subtraction is not commutative. So you have to do it, the numerator, in this order. Always remember low first. Low d high minus high d low over the square of what's below. Common mistake is to get the numerator switched around. But wait a minute, if subtraction is the same as addition and addition is commutative, how come subtraction is not commutative? Side note. You know, addition's commutative, 5 plus 2 equals 2 plus 5. But hasn't my teachers always said subtraction is really addition? Like 5 minus 2 is really 5 plus negative 2? So shouldn't subtraction be commutative? Well, careful, 5 minus 2 is 5 plus negative 2, but 2 minus 5 is 2 plus negative 5. They are different additions. That's why it's not commutative. And yes, this is obviously 3, and this is negative 3. Just a little side note there. So you got to get the numerator order right. It's very important. You get it wrong in the gateway, it's a wrong problem. No partial credit on the gateway. All right, let's apply the quotient rule. To, for example, take the derivative. How about of x squared divided by e to the x? Hey, you know what? That's the same problem we just did with the product rule. Because x squared times e to the negative x, because the negative exponent there is the same as x squared divided by e to the x. We should get the same final answer when simplified. Okay, so e to the x is the low function, x squared is the high function. This quotient rule says low d high, take the derivative of x squared to get 2x, minus high d low. What's the derivative of e to the x? E to the x over the square of what's below. And yeah, you could use a property of exponents to rewrite that as e to the 2x, but you don't need to. And in fact, it's better for simplification purposes not to, because we can factor to simplify and e to the x out of the numerator and cancel it with one of the ones on the bottom. and write our answer like this. And because dividing by e to the x is the same as multiplying by e to the negative x, this is the same answer we got before. Here's the way we originally wrote it before. It's the same answer as before, right? This is the problem we did before. Take the derivative of x squared e to the negative x. We did that with the product rule. One way to write the answer was, like I just wrote 30 seconds ago, this way. We could also factor out whatever we wanted to factor out, the common factors. Yep, there's the same answer. It also happens to equal this, it happens to equal this, it happens to equal this. If you encounter this problem on the gateway, how should you leave your answer? Actually, any of these is right. Any of these would give you full credit. But if you try simplifying like I did here on the gateway, you probably make a mistake, right? So you probably want to just leave your answer like that on the gateway. That's good enough for the gateway. I have mentioned before that the derivative of sine of x is cosine of x, and the derivative of cosine of x is negative sine of x. This is not going to come up on the homework until next week, but I've mentioned this before and I'm mentioning it again. By the way, for these rules to work, it is required for x to be measured, so to speak, in radians, if you're thinking of x as being an angle. Now, you don't have to think of x as being an angle. Whether you think of an input for sine and cosine as an angle is up to you, kind of. It depends on how you want to think about it. You can think of it as an angle if you want, but you don't have to. If you think of it as an angle, it must be in radians. If you graph it in your calculator, it's got to be in radian mode, not degree mode, for these to be true. Because if you were in degree mode, you're really getting different graphs. You're getting different functions than what we're calling other true graphs of sine and cosine or period 2 pi. Let me use this in another quotient rule problem. Let's let f of x be, well, let's even combine some rules here. How about f of x is e to the x sine x divided by x squared? What's the derivative of that? Well, first of all, it's a quotient, a ratio, a fraction. I need the quotient rule. Low d high minus high d low over the square of what's below. Low d high, for that one, I need the product rule, don't I? Let me just write it like this first. Let me not differentiate it yet. Low d high minus high d low is the derivative of x squared. That's 2x over the square of what's below, x squared squared, which is, yes, x to the 4th. But here I also need the product rule. This is really a two-step problem. You first use the quotient rule, then you need the product rule to finish it. This is not good enough for the gateway yet because we need to take that derivative there. And yes, also be careful about parentheses. I need to multiply x squared by the entire derivative of this product, which is going to be the sum of two things. I need parentheses. With this thing, e to the x is the left function, sine of x is the right function. Left d right, what's the derivative of sine? It's cosine. Minus or plus, lefty right plus right d left, but the derivative of the left is also e to the x, because the derivative of e to the x is itself. And yes, multiplication is commutative as well. I could have the e to the x in front of the sine of x there. Rewrite the other term here like this, and simplify the bottom. X squared squared is x to the 4th. That is good enough for the gateway. Is it good enough for using the derivative? I'd try to factor the numerator as much as possible. There is a common factor of e to the x that can be factored out. There's a common factor of x that can be factored out. If I were to try to use this derivative to figure out where it's 0, positive, and negative. Still probably would be a pain to figure out where it's 0, positive, and negative because the cosines and sines. But maybe we could do it. I'm not so sure. But stop and think about this. This is amazing. No limits. Aren't we happy? No limits. Yet we found the derivative of this function. It's a complicated derivative, but it's the answer if I haven't made a mistake. Tell me if you think I make a mistake, by the way, because I sometimes do. Would I always get a perfect score on the gateway? Well, not if I was feeling sleepy, probably not. But I mean, I got time to double and triple check and quadruple check things, so I probably would. But okay, it's amazing.